The most basic kind of equation that you will solve involves something that will be familiar to you from the unit circle. So let's suppose you see an equation that says solve for all solutions. Now you have to really be careful with these directions, because when it says solve for all solutions and you're talking about solutions that are on a unit circle, for instance, let's say you had an equation that said cosine of x equals square root of 2 over 2. That should be familiar to you by now. And when you think about where square root of 2 over 2 is, that involves a 45-degree angle. And, you know, this could be, the directions could say find all the solutions, and it could say in degrees, it could say in radians, it could say like this, 0 degrees to 360 degrees, something like that. It could say from 0 to 2 pi, like that. It could say from 0 to 2 pi, like that, with brackets around it. And remember, when you learn this in pre-calculus, you learn that a parenthesis means that something's not included. So if they showed those parentheses like that, it might mean that it doesn't stop at 360. Maybe it keeps going. If it has the brackets around it, it means it's just the circle. So when it says all solutions, it means every single answer you could possibly think of. So cosine, remember, is the x value. So at 45 degrees, the x value is square root of 2 over 2. And in the first quadrant, it's positive. And since this one is positive, we're looking for where the x value is positive. Now, you also have 45-degree angles in the other quadrants. And remember, you have 4 reference angles. There are these 4 angles right here. And in the second quadrant, your x value is negative and your y value is positive. So we're not looking in that quadrant because we're looking for the x value to be positive. In the third quadrant, it's negative and negative. So we're not looking in that one. However, in the fourth quadrant, you have a positive and a negative. So in the fourth quadrant, cosine is also positive there. And so the 45-degree angle that's there would be 360 minus the 45, which would be a 315-degree angle. So you have 2 places where cosine is square root of 2 over 2. And not only do you have those 2 places, so on your circle, you have this place and you have this place. But every time you go around that circle, you go around those 2 places. So you pass square root of 2 over 2 every single time you go around the circle. So when we solve this equation, we're trying to find where x, we're trying to get x by itself, so we're saying, where is x? Where's the cosine of that x, square root of 2 over 2? And we can say, well, x happens to be 45 degrees, but x also happens to be 315 degrees. But it's also everywhere you pass the 45 and everywhere you pass the 315. So sometimes you'll see this notation. And the k is a constant that just means the integers. And it's the counting numbers, 1, 2, 3, 4, 5, 6. And even the negative ones, because if you go backwards 360 degrees, from that point, like let's say I'm at this point, if I go this way every time I pass that negative 360 degrees, I'm going to have square root of 2 over 2. So this notation means it's at 45 degrees, and every time you go 360 degrees, once, twice, 3 times, every single time, it's at 315 every single time that you go there. So that's the solution for that when we say for all the solutions. This one happens to be example 1 on page 604. It says find all possible exact solutions for the equation cosine of theta equals 1/2. And if you look at the unit circle, it's asking you, this is saying, where on the unit circle is cosine of an angle 1/2? And in this particular problem, they're going to give you your answers in radians. And so it says, well, on the unit circle, at pi over 3 and at 5 pi over 3, cosine, the x value, is positive 1/2. So if the directions had said, find the solutions in the interval from 0 to 2 pi, it's saying, on your circle, starting at 0 and going to 2 pi, so if I start at 0 and I go to 2 pi, that's one time around the circle. So if I had said that, I'm only asking for those two answers because those are the times that it happens on the circle. If I say find all the possible solutions given by that, this is the way your book gives these solutions. And so it gives two solutions. And the reason it gives the solutions like that is it's saying, okay, when I go around the circle at pi over 3, my cosine is 1/2. But if I go around the circle, 2 pi is 360 degrees, and then the k is the number of times it goes around the circle. And they just simply, the notation, it could have been 2 pi k. I mean, it could have been written either way because multiplication, you can go in any order you want to. So it's just telling you, just like in the previous example that I did, that this is the same no matter how many times you go around the circle. And it puts a plus or minus in your book to show you that it doesn't matter if you go clockwise or counterclockwise around the circle, every time you pass the pi over 3, you're going to get a cosine of 1/2. Same thing with the 5 pi over 3. Every time you go around that circle in that same spot, you're going to get the 5 pi over 3. So that's what these examples mean. So when you're looking at these problems, pay close attention to the directions. If it tells you that it just wants, pay attention to where it's asking for the interval. If it says it wants an answer in this interval, it's saying we want all the answers that are on the circle from 0 to 2 pi. If it says all the solutions, it wants an answer like this one. So you need to pay attention to the way it's phrased.